APBC Calculus student, this is an introductory video about partial fraction decomposition and integration with partial fraction decomposition. So let's take a look at this integral. The numerator is x minus 1, denominator is x squared minus 2x minus 3. So first let's check if the u sub works or not. So choice of u is x squared minus 2x minus 3, and if I take a derivative, this will be 2x minus 2 dx, and yes, you can easily see that u sub fits very well here. So that means you can clearly see u prime over u, and this will be, if I rewrite, is as 1/2 u du, and the answer will be 1/2 ln of x squared minus 2x minus 3, and don't forget c. So this is a quick review of u sub. This is, you cannot factor x squared plus 1 and recognize that u sub does not work, because if I say u is equal to x squared plus 1, du is equal to 2x, I do not have x there. And you should recognize from the pattern that this is one of the inverse trig function. And you should remember that this is tangent inverse x plus c. So these are the two fractions, and we managed to use other techniques of integration, which one is a u sub and inverse trig function. So let's consider another integral where 5x minus 3 is in the numerator and denominator is x squared minus 2x minus 3. Now we have the same denominator as the previous example, but you can see clearly that the numerator has a 5x minus 3, so u sub does not work. Okay, so let's check if I can separate the integral, which we talked about that before. 5x over x squared minus 2x minus 3 and negative 3 over x squared minus 2x minus 3. Even if I separate the integral, I can still not use u substitute method. So still does not work. So what technique we should use here? So let's take a look at here. When your integrand is a quotient, it's a rational function, if it does not fit any formula, or you cannot do the long division, you can see that this is the bottom heavy, you cannot do the long division, then can you factor the denominator? Can you break up the denominator into multiple parts known as factors? Are the denominators of your parts degree 1 or degree 2? What that means is the linear factors. The parts has to be degree 1, means mx plus b factor. Degree 2, that means a quadratic factor. Now when attempting to integrate a rational function and u sub fail, we should use a partial fraction decomposition. The procedure of decomposing a rational function into simpler rational function is called method of partial fraction. We did learn this in pre-calculus, but I don't suppose that you remember that part. So first of all, let's review how to rewrite into two simpler fractions. So the first thing is factor. Factors of 3 to get 2 is x minus 3 and x plus 1. You must be able to factor. So that means I'm rewriting one of the factor is x minus 3 and the another factor is x plus 1 dx. As a placeholder, we write a and b. Our job is to find the values of a and b. So if you recall from pre-calculus, I put the integral sign aside and I combine this fraction. That means a needs to be multiplied by x minus 1, b needs to be multiplied by x minus 3. And denominator would be x minus 3 and x plus 1. I'm putting the integral sign aside, and let's check what do we get on this side. Our job is to solve for a and b. So there is a shortcut here. You don't have to do all the way to get the system of equations and all that. All you need is the numerator. 5x minus 3 is equal to a x plus 1 b x minus 3. You can clearly see this factor will be 0 when x is negative 1. So substitute x equal to negative 1. 5 times negative 1 minus 3 is equal to, this becomes 0, b negative 1 minus 3. So 5 times negative, this is negative 8. On this side is negative 4b, and you will get b is equal to 2. If you do the same thing, this factor will be 0 when x is equal to 3. Substitute x equal to 3 here. So 5 times 3 minus 3 is equal to a 3 plus 1. This b will be 0 because b times 3 minus 3 is 0. So 5 times 3 is 15. 15 minus 3 is 12. And this is 4a. And the value of a comes out 3. This is the piece you have to remember how to do from pre-calculus class. So now comes calculus part. Calculus part is, let's rewrite this integral. Value of a is 3. So 3 divided by x minus 3 plus value of b is coming out 2. X plus 1 dx. Now let's take a look at this. How cool this is to integrate. Antiderivative of 3 over x minus 3 is a quick review from calculus class is what? Antiderivative of 1 over x is ln x, if you recall. So here derivative of x minus 3 is 1. So I can easily pull out 3 ln of x minus 3 plus factor out 2. Derivative of x is 1. So ln of x plus 1 plus c. So this is the answer for original function. Let's do another example where I'm going to show you another way to find the value of a and b, which I call it finger method. There are two different examples. I'm showing you two different methods to find the value of a and b. This is the method we showed you in pre-calculus class, but in calculus there is another easier way to find the value of a and b is, let's do another example to show you different method. So again, factor is x and x plus 2. Let's rewrite a over x, b over x plus 2. Our job is to find the value of a and b. Integration comes later. First, find the value of a and b. So that another way to do it is, let's say x is equal to 0. Hide this integral 1 over, if I substitute x equal to 0, this factor will be 0 when x is 0. So if I substitute 1 over x plus 2, that means 0 plus 2, I get 1/2. That means value of a is 1/2. This factor will be 0 when x is negative 2. So here substitute, take it out and put 1 over x is negative 2. So that means b value is negative 1/2. If you are not convinced, let's do the original way we did up here. Okay, so I'm going to show you the original way if you did not understand what I did here. We call it a finger method. That means finger method means you hide it and then you, whatever is left out, you substitute the value. So let's do the original way we did it. A needs to be multiplied by x plus 2. B needs to be multiplied by x, and on this side I have a 1. Substitute x equal to 0. That means 1 is equal to a times 0 plus 2. a is 1/2. Substitute x equal to -2 when this factor will be 0, which is 1 equal to b times -2, and b will come out -1/2, which is the same as here. Okay, so now this was the pre-calculus part. Let's not forget our original question was, how do we integrate 1/2 over x plus -1/2 over x plus 2 dx. This becomes 1/2 ln x. Absolute value bar must be necessary. It must be there. Absolute value bar must be there. Minus, I can take out the negative sign outside, 1/2 ln x plus 2 plus c. Now here I would like to review the properties of log. Log properties are, let's quick review of log properties, is ln x plus ln y. It is a product. And if I have ln x minus ln y, then it is a quotient. These properties are properties of log pre-calculus. You must know these. You must know these because many times in multiple choice question you will not see this answer. This answer will be simplified, which would be ln, I can factor out 1/2, and ln x minus ln x plus 2. C will be out, and simplified answer in a multiple choice would look something like this. So no properties of log. So again, u sub does not work because derivative of denominator is not there. It's easy to factor the denominator, which we factor, find the values of a and b, and then back to normal integration method. Now, this 2a is the same question with the bounds 2 and 4. So here, I'm using the same answer with the bound 2 and 4, which becomes fundamental theorem of calculus, and the answer is a number. So I'm going to bring this answer here. 1/2 ln x over x plus 2, bound is 2 and 4, which will be 1/2 ln, if I substitute 4, so that becomes 4 over 6 minus 1/2 ln, if I substitute 2, it becomes 2 over 4. So final answer of this would look like, again you have to see how this is properties of log 1/2 ln 4/6 over 2/4. Whatever you simplify, not simplify. If it is a multiple choice question, the answer would look like either 1/2 ln 4/3 or ln square root. This you can take it up as a square root also, 4 over 3. So know the properties of log and know how to simplify a definite integral using logs. I'm going to stop here. We will do more problems in the class. Thank you.